All right. So for the OCI specification, you need to know about myelination of a neuron. So obviously there are myelinated neurons and there also are non-myelinated neurons. So from GCSE, you should remember that myelin is a substance secreted um, that surrounds a neuron, and it basically increases the speed of transmission. Now, myelin, I guess an advancement that you need to know for eye level is that the myelin is secreted by cells called Schwann cells. I've shown those in green, and they basically line the neuron, and they secrete myelin that cakes on top of them. So you've got this. It's sort of like icing on a cake. That's a nice way to think about it. So another advancement for eye level is that the myelin is discontinuous, and the reason it is discontinuous is because you have these areas where there is no myelin, and myelin is incapable of having, or at least allowing the membrane to have voltage gated sodium ion channels in it. If there is myelin present, then there will be no voltage gated sodium ion channels. So myelin, in fact, I'll write this down now for you. So myelin equals no ion channels. So myelin equals no ion channels. So why is this important? Well, the ion channels have to be present somewhere, and the place that they are present is in the area where there is no myelin, and we call these areas the nodes of Ranvier. That is a key term. You should note that down. And at the nodes of Ranvier, you have loads and loads and loads of voltage gated sodium ion channels present to allow depolarization in these regions. And a good way that you can think about this in terms of like why does this actually increase the speed of transmission is it gives what we call longer local circuits, and that's because it provides insulation, electrical insulation. That's just a phrase you want to think about or remember, that it provides electrical insulation. But the fact that only voltage gated sodium ion channels are present at the nodes of Ranvier means that it means that the ions can only enter at one place. So if I illustrate like what a short circuit actually means, well, if you've got your neuron here, I'm just going to scribble two lines out there. Um, if you have loads and loads of ion channels all across the neuron, what this will mean is that there is a delay every single time, because these gates have to open, and then these gates have to open to carry on the transmission, and then those gates have to open, and this is time consuming. Okay, that would be time consuming. And because you've got like many you've got many short local circuits, so shorter local circuits without myelin. So shorter local circuits without myelin. However, when you have myelin present, obviously we know that the voltage gated sodium ion channels are only present, are only present at the nodes of Ranvier, and the nodes of Ranvier are pretty far apart. So what does that mean? It means that the nerve impulse can literally just travel like this. It can go straight across there. It doesn't need to have any delay caused by the opening of gates, and then it can go straight along there. Okay, so that is what we mean when we say it has longer local circuits. Now, the other thing that you need to be aware of, so we've mentioned that it has longer local circuits, and then there's just a general phrase, that myelin provides insulation. Um, Two more terms that you really want to think about is uh, in relation to what I've just described with the longer local circuits. It's the idea of saltatory conduction. So like almost like the electrical impulse is jumping. It's jumping between the nodes. So it like jumps between the nodes. And if you actually have studied Spanish, you'll recall that saltar means to jump. So saltatory conduction means to jump between the nodes. So that's what myelination allows. It allows for saltatory conduction. And the last point is capacity. That the fact that myelin acts as a capacitor. You don't need to know what this means in too much detail. It is university level, but I've drawn it anyway just for your understanding. So the Na plus ions are trying to move through the neuron, but there are many negatively charged ions around the outside. Now, notice here, notice here, for example, that there is no myelin present. Now, if there's no myelin present, obviously this would be a node of Ranvier, but let's just assume for a second that this is a section of a non-myelinated neuron. What would happen is the negative anions would attract to the positive sodium ions, and then these positive ions would not be able to move. So they would not be able to move across the neuron, okay, because those would be hooked up to each other. They would be attracted to each other. But the fact that we have myelin means that the ions, the positively charged ions, are separated. There's this distance between, actually, let me just redraw that. There's this distance between the ions. They're kept apart. In reality, it would probably be like this. The distance would be much smaller. But obviously the myelin's not going to be that big. But notice that this distance there, there's distance maintained between the ions so that the sodium ions can still flow through the neuron. Okay, but you don't need to worry too much about that. So that is myelination. Hopefully that has been useful for you. I would also recommend going through some diagrams, through practice questions for labeling squam cells. It's very application based. You're meant to apply your logic of like organelles and nuclei, and basically do practice questions on this topic. So yeah, good luck.